Hi everyone, welcome to the YouTube channel of ChemLover. So today basically I am going to solve two questions over here. These are the doubts which have been asked by one of my students. So let us try to solve this question number first. In this question we have to assign E and Z configuration to the following compound. So this is the compound given and we have to assign E and Z configuration. So in this compound, this is the carboxylic group. This is carbon number 1. This is carbon number 2, carbon number 3, carbon number 4, carbon number 5, 6 and 7. Now we have to assign E and Z to the compound. At this position, I will star mark this position and at this position. Isn't it? So at position 2 and at position 5, we have to assign configuration. So let us try to solve this question by assigning E and Z system of nomenclature to this compound. Let me write down this question once again. So this is the question. Over here, this is the question. Over here, we have COOH group. Now, how we assign E and Z system of nomenclature to the compound? We have to use CIP rules. What are CIP rules? These are Cohen, Ingold, and Prelong rules. These are the priority rules. I have to apply these rules. So we assign priority on the basis of atomic number. Now see, this is the carbon-carbon double bond. This is the compound. This is the position where there is carbon-carbon double bond. To this carbon-carbon double bond, there is COH group attached. And over here, we should have a hydrogen atom. Over here, we should have a hydrogen atom. Now, let us see the different groups on this compound. So assigning CIP rule is, since this carbon which bears carbon-carbon double bond, that means sp2 carbon, it's attached to the carbon, and over here it's attached to hydrogen. The carbon has higher atomic number, so it will be given priority first, and this hydrogen will be given priority second. So this is priority first, this is priority second. Now after assigning priorities on this carbon, now we'll assign priorities on this carbon. So over here it's attached to hydrogen, and on this side it's attached to carbon, this type of bulky group. So let's assign. So over here it's hydrogen, it's carbon. Carbon has higher atomic number, so this is given priority 1 and this is given priority 2. Now if the similar priority groups are on the opposite side, then it is known as E configuration. Now see, the similar priority group, priority 2 and priority 2, they are opposite to each other. Priority 1, they are opposite to each other. So this carbon is having E configuration. We have numbered this carbon as number 2. So at 2, we have E configuration. So it is 2E basically. Now coming to this carbon atom. So over here, if I look at this carbon bearing carbon-carbon double bond, we have one group attached over here. This group is methyl group. This group is methyl group. And on the other side, there should be hydrogen atom present. Likewise, over here we have a carbon, this bulky group present, and on this side we have hydrogen atom. Now assigning priorities, carbon is having a higher atomic number, so its priority is 1. This is the second priority. And coming to this carbon atom, over here hydrogen and carbon is attached. This carbon will have priority 1 and this hydrogen will have priority 2. Now you can see over here the similar priority groups are on the same side across carbon-carbon double bond. So at this position of the alkene, this will have Z configuration. Now let us see, this is carbon 1, this is carbon 2, this is carbon 3, carbon 4, carbon 5. So at carbon 5, there is Z configuration. So it is 2E5Z. So it is 2E5Z. So the correct option becomes option number 2, that is 2E5Z. So coming to the next question. So this is the next question. Which one is not the metamer of the following? So here we are given 4 options. We have to tell which one is not metamer of the following. So let us understand first the concept of metamers. Metamerism. So what is the necessary condition for a compound to show metamerism? It's a type of isomerism. Now what is the necessary condition? Necessary condition is there should be a bridging functional group. Now what do we mean by bridging functional group? Like we have this type of group, there is oxygen attached, this is a bridging functional group. We have C double bond O attached, this is a bridging functional group. We have sulfur attached over here, this is a bridging functional group. We have NH attached over here, this is a bridging functional group. Now let's take an example of this metamerism. So for example, I have this type of compound CH3O, CH2, CH2, CH3. So this is one example I have taken over here, and I'll take its isomer. So isomer I can write like this: CH3, CH2, single bond O, then CH2, CH3. Now let us try to understand, are they metamers or not. See over here we have how many carbon atoms? 1, 2, 3 and 4 carbon atoms. Matlab it is C4 है ना. Or here it is C4, and hydrogen atoms 3 plus 2 5 plus 2 7 plus 3 10. So it is C4H10. The molecular formula is C4H10O. Over here, one carbon, second carbon, third carbon, four carbon. Matlab it is again C4, hydrogen 3 plus 2 5 plus 2 7 plus 3 10. Matlab H10O. So they have same molecular formula. But where they differ? They differ in the presence of the groups around this bridging functional group. This is a bridging functional group, and this is a bridging functional group. In this case, on one side of the bridging functional group, we have methyl group, and on the other side, we have propyl group. And in the second one, we have ethyl group on one side and ethyl group on the other side. Such type of isomers in which there are different type of alkyl groups present across this bridging functional group, they are known as metamers. Now we have to see, this is a compound given. In this compound, we have to see which one is not its metamerism, which one is not its metamer. So let us see this compound. Over here we have bridging functional group. In this case, you can see over here we have a bridging functional group. This is a bridging functional group, that's ethyl oxygen atom. Over here there's a bridging functional group. Over here there's a bridging functional group. Over here there's a bridging functional group. But coming to this type of the compound, there is OH. OH is not a bridging functional group, it is an alcoholic group. So it does not contain, there is no bridging functional group. There is no bridging functional group, hence this is not a metamer of this compound. Clear? I hope this thing is clear to you. Thank you.